Hi, my name is Pietari Sarjakivi, and this is the fundamentals of threat detection in OT and ICS environments. We have now luxury of half an hour, 45 minutes on these topics, and topic, as mentioned, it's trying to cover the fundamentals of this OT side. First of all, who am I? I'm working at Nixu and been there for 12 years now as a various leader position and a specialist position, varying from CISO to the business area leader. I also do blue team training and stuff like that in NPK, the National Defense Association, and on my Corona hobby, I just started my PhD studies in Jyväskylä University. Why I am here? It is this is one of the reasons. So we have just about to finalize. We're about to finalize the book about the OT security, or it's actually a revision of existing book. And it's published by Suomen Automaatio-seura. It's in Finnish language. Sorry about that. And it's aiming to kind of teach the basics of cybersecurity for the so to say OT specialists and OT people. And together with Jari Seppälä, we are writing a chapter about the monitoring there. So this is the kind of the reasoning. The reasoning for you to listen this call would be that you might be interested to understand the OT side of cybersecurity a little bit better, and that we will going to spend the next half an hour with this agenda. First of all, we are going to go through the environment. So how does the things go in the OT world, and if you don't remember anything else from there, you should remember that the Purdue reference model and how the OT world is supposed to be mapped, and also we are focusing on the knowing the enemy, so what kind of attacks might be there, and the thing to remember is the Mitre attack for ICS. And in the defense side, that is kind of the main beef of this presentation, and kind of my own expertise area. We're going to go through a couple of use cases there. But hey, let's start with the environment understanding and definition. First of all, if we think the OT or ICS world kind of in an overly simplified way, we just take the physical things like raw materials and do some magic for them, and then the company gets, or organization gets, some profits, some benefits out of that. No matter if it's a kind of steel and we make spoons out of that, or it is some kind of coal and we make electricity out of that, or wind. Of course, that's not in a traditional sense raw material, but something that is generated in the process. So it is a process. A little bit slow. My slides are changing. Hopefully this goes well in the future. Couple of definitions. The OT and the industrial ICS terms. The Gartner says clearly and nicely something like this: hardware, software, direct monitoring assets, physical devices, blah blah blah. It's well, it's kind of Gartner way of saying things. I like a little bit more on that what Shodan tries to tell us. So the ICS are the computers that control. So they're computers that control the world around you. They're like air conditioning in your office, turbines in the power plant, or lighting at the theater, robots in the factory. And there's a lot of acronyms and terms in that world that try to kind of map here. I copied this from internet, but still, in my world, the OT and ICS are almost the same when I use those kind of combined. And there's SCADAs and DCSs and PLCs and RTUs and stuff like that. Just for you to know, we are not going to go that deep into how that side works. But what we are going to do is to kind of try to understand why this is relevant for you now. And one of the reasons is the Industry 4.0 or so the fourth industrial revolution, or even fifth, and so on. But these things that were originally relatively manual, and someone invented that they need to kind of fine-tune the process even deeper. They started to be computerized and some automation in there. And in the fourth industry revolution, these things are trying to get smarter in a way. They're trying to be autonomous. There's a lot of industrial IoT things. These are connected. And just machine-to-machine communications, and of course they are remotely managed over 5G or 4G or whatever networks you have there. So instead of kind of trying to prevent or predict what would be the demand in the future, these are and where they get the materials, they try to be quite much interconnected to each other, which is kind of not the way how this has been done for years now. So and typically these devices don't so to say talk to each other too much. They are not meant to be connected for the internet, but now they are. And the life cycle of these devices tends to be relatively long, so they are used for many years. Yeah. In the more, so to say, technical network-oriented way, this is how the OT world can be imagined or mapped. Nobody actually ever has network like this, but this is more like kind of the reference model. This is from the, if I recall right, from year 1990, so 30 years old model, and here the kind of the basic mapping is that the first couple of layers, level 5 and 4, the normal ID that you most likely have been used to play with, and there's the normal, well, I don't need to explain that. The normal monitor and detection, threat detection capabilities are there. Then on the, so to say, the OT side, the completely unofficial term is the IT like OT that I kind of invented when I tried to explain this. So in this level 3 and 2, the smartest of you already noticed that these go basically from in a way wrong order. So in this world, the kind of the devices are quite much same. As you can see, there is things like domain controllers there, and kind of, so to say, normal stuff, but they are used for the OT purposes, and the kind of the laws and principles are in a way more OT than IT, and as you can see from the network kind of topology, the DMZ firewall here is playing relatively important role. How this works in this world, if we think that for example, the management of the network is happening from the control center here in the level 2, the data, but the data is needed in the kind of, so to say, in the headquarters. For example, the historian device sends data to the historian proxy or in the DMZ and then sends back to the business servers. A little bit similarly, there will be some remote users, hopefully from the enterprise network, not always like that, but hopefully accessing the remote jump server, and from there accessing the rest of the environment. As mentioned, there's normal tools like domain controllers, which have their own kind of good and bad sides, and when it comes to cybersecurity. Then the third part here is the OT side of the world, where, well, things are completely different, and here if we think that in the picture again, the engineering workstations and the HMI users are using the IO server that is sending the request for this magical land of OT here. If I go a little bit deeper, as soon as my computer allows me to do that, let's see how this thing is operated. So in this OT environment, level 3 to 1, there is human machine interfaces, basically someone running this process or overseeing, because computers are running, but someone monitoring, most likely 24/7, that the process does what it's supposed to do. There's devices in the field, so to say. So in the upper ones, that they can be in the control center, and those other devices can be basically right next to the physical OT thing. Then there's the historian device, typically, that actually process log archive. So the data will be gathered there. There's also someone, this is kind of took me a while for understand that the people who is running this thing is not in a way improving or changing the whatever process there is going on, but there's separate engineering workstations where someone is kind of creating a new formulas for the whatever thingy there is that we are creating. And again, as mentioned, there's in the real life, in the level 0 and 1, there are kind of things that are typically in a closed loop. There are automated systems that are controlling the flow with the valves and relays and switches, not network switches, but physical switches, and some things that are measuring the flow with the visual motion temperature sensors also. And this all is kind of optimized for the availability. So when in IT world, we are kind of used to understand that the confidentiality is one of the most important things. This is, of course, it's not that kind of necessary. This is kind of generalization of things. But in OT, it's basically always the availability and, of course, the integrity of the whole process. So it's in theory, it doesn't matter if things go really south with the process. Things go kind of, you leak the data, but if the things go south with the process, there will be physical damages done. But yeah, OT in real life, first of all, those systems are the most critical asset for many organizations. There will be different type of processes, as mentioned earlier. They're just valves and sensors in a way, and one can use the same system to brew a beer, or someone can make electricity out of coal or nuclear, or whatever is the process. The technology still is the same, but how you basically build that it varies heavily. So basically, it doesn't help that if I know OT, I know the basic principles, but I don't know what this process is doing. There's quite much different variations when it comes to, so to say, the OT side of regulation, not the product itself. For example, if you make food, nobody is interested how your OT system works, as long as you, of course, it is hygiene and so on, but nobody doesn't give a damn if it's not kind of operational today, because you have some storages and so on. But when you're operating nuclear power plant or you're making healthcare devices, then there's relatively strict legislation demands for that. So in a way, OT is different in that way as well. And the networks vary heavily. Some are using the completely flat network without no segmentation, and some people are using data diodes. Some of them are using the data diodes to kind of make sure that the data flows in, and some of them are using to make sure that the data flies out. Depends on if you need to report or if you need to update things. There's a lot of vendors. In Finland, we have kind of one dominant player, but many others exist, and basically they don't talk to each other, and they typically are quite independent, so to say, standalone units. They might have their own facility leader or manager who's basically, it doesn't matter what the corporate says, they're doing it anyway. And in many cases, there's a lot of external people in the network, and typically those are maintained, so to say, in the maintenance breaks that might be really massive. There might be hundreds of people in your site just fixing things to make sure that the downtime is as small as possible. So that would be the kind of the environment that where we are living in. Now let's focus on the enemy and who we are in a way against. And yeah, everyone needs to have the Sun Tzu quotes here. I actually in some weird way really like these. But basically, when you're defending something, it's really smart to know what might be you might be against and what they might be interested. So that is kind of the idea here. So this is let's use the Purdue model, by the way, to basically map these attacks and defenses, and kind of couple of possible attack paths. For example, for ransomware, that is more and more common, unfortunately, and making huge damages here. You don't need to kind of go deep into the deep OT magic side, but it is enough that if you just basically prevent anyone to control the systems. There might be some local HMI devices, like here. Maybe you can see my mouse, maybe not, and they are literally time to time those wall-mounted tabs type of things. But yeah, and the attack might look like in a way that someone compromises the laptop in the enterprise side. They gather the credentials and go to the jump server. From there, they somehow get into the engineering workstation or something else. And from the engineering workstation, as mentioned earlier, you can control the actual devices like everyone else is using. And of course, you can on the way get the domain controller and well, you know, then you get everything in the environment. The HMI is quite good as well. Of course, typically they don't make that great changes from there, so it's kind of better for attacker to kind of operate from engineering workstation. And then of course you can, so to say, if the attacker wants to make physical damage, it's possible to kind of go deeper. Then you need to a little bit understand how the process works and how to suddenly kind of turn the spinning direction or swap the spinning direction of some turbine or whatever, and make the devices jump, as you can see from the internet. But here we basically need to just add the kind of the understanding. Just add the understanding of the process. This is typically the most difficult thing here. Then, of course, there's a specific ICS malware like Stuxnet that got to the environment using USB stick. I didn't find that quickly if the USB stick was put into the kind of closed network of the enterprise environment here, or was it inserted into the engineering workstation or so? But basically the isolated network, and then since you cannot control this and you need to know this, you need quite a lot of knowledge how this would be run and operated without anyone noticing. And yeah, basically you're controlling these. Sorry, my automation failed. Then there's Triton malware that is really nasty because the OT environments, the kind of the fear is that someone might get hurt because there's a kind of, so to say, cyber physical systems, and the Triton did nasty trick by touching the safety instrumented system, so SIS here, and the thing here is that the SIS. The point with the SIS is that you just need to, if the human is stupid enough not to fix the process or making some critical mistakes, doing some stupid changes, the SIS system should basically prevent anything to actually physically break. So in theory, it is a system that prevents me to break this facility. But if that's not operational, like in Chernobyl or like victims of Triton, the human mistake can cause some bad things. And of course, normally you should not go into the mode where the SIS kicks in, but I believe that some operators time to time kind of little bit lean towards the SIS system. Again, I don't know. Nobody dares to tell this type of things, but I expect that it is. I mentioned in the beginning that you need to know the Purdue model and a MITRE attack for ICS. This is the attack matrix, and since we don't have time to go this through completely, I will just highlight a couple of things. For example, the initial access, the engineering workstation compromise we went through, or the internet accessible devices. And one might think that, hey, these things should not be connected to the internet. Shodan says differently. This is from this morning, if I recall right, or yesterday evening. And there's still quite many devices. Some of them are honeypots, but still quite many devices that you can directly contact with over the internet. And well, of course, if you know how to search, you can do many other things. You can find many other things. The replication through removable media mentioned already in the Stuxnet case, and then of course the rogue master device, which is relatively actually a good way, since those are physically large areas where those systems are, and if you're able to kind of insert your own PLC or whatever controlling device as part of the network and just yell a little bit louder than the actual device, you can mess up with things quite badly. But yeah, these are kind of the how to get in. Since this was supposed to be fundamentals, we are not going to go too much deep into the kind of how and which type of damage you can do. Just saying that in the right side of the matrix, there are a couple of really ICS specific things related to how you can do how you can manipulate the system, and this radar picture here is from the yet another great paper called ICS cyberkill chain, and there people are trying to map how difficult it would be to conduct different type of, so to say, damages, or not to get in, but actually do some harm in the environment. And as mentioned, as described in the top of the picture. The getting in is relatively easy, and but doing kind of actually touching the process logic there, it is much more demanding. Well, it is not because it's kind of physically protected or in the technically protected better, but it is mainly because of the kind of the you need to know the process quite well. So this is the kind of the attacker's side. Then let's go a little bit deeper into the defense side. The typical controls in the OT environments are listed here. I'm not saying that everyone does things like that, but quite often you can see the planned DMZ firewall and patching of some operating systems whenever you have a big maintenance break, if you happen to have time that year, because there's quite many other people doing quite many other changes there. It's not that bad always, but one should assume that it's not much better than that. Of course, there is advanced companies who are having more advanced things like completely isolating or the plan from others, or having data diodes. Basically, it's systems that allow only one directional traffic. For example, send the data from historian to the enterprise, or sending updates from the company's own update server to the OT environment. They might do some patching more often if they, for example, have continuous connection for the data, you can get patches and so on. They might have some segmentations there. Of course, what I forgot to mention in the beginning is that there's typically quite many of these factories and sites. Quite rare actually that someone just has one OT site. So there might be some interconnection between the OT sites as well. There's this weird thing that I have seen in some places, that this type of USB stick malware testing station. So box where you go and insert your USB stick, and then it runs the malware scan and reports you that, hey, this doesn't have any malware in. So basically. Well, of course, those are quite nice attack vectors, but it's kind of USB cleaning station. And quite often OT vendors have their own central logging systems for the operational efficiency purposes there. If we go a little bit deeper and see the kind of the visibility at the monitoring side from let's use the Gartner SOC visibility triad as a kind of platform for us. Let's start with the log-based monitoring, so top side of the triangle. So there is kind of typical, as mentioned, the logs are generated, but how useful they are. How do you collect those? Do you collect them? Do you install some agents? Do you collect them from the network tab, or how do you do that? Standard SIEM rule sets typically need heavy tuning, although they quite often need heavy tuning even in the IT side, but there's a chance that for example, your SIEM doesn't even understand. It cannot even parse the logs, and I don't blame them. The quite useful tool for this type of environments is that if there's some kind of anomaly detection or user entity behavior analysis tools that actually run some kind of baselining for the logs. So they don't need to understand that, but they see that, hey, I have never seen this type of event before. And as mentioned, that there's typically some OS operating system logs, but these vendor-specific logs can be quite demanding to understand. I took one example here. So this is error message from the Valmet DNA, one of the largest players in the Finnish market, and of course this is not from the latest version, but neither is the kind of the your customer production. So this is the log entry. You just need to kind of understand that the first letter is name server, whatever that means in that context and in that protocol, and diagnostic name and station name and cards log, and it says fault. And from that you need to understand that something is not functioning in that specific card. And since this kind of the closed circuit type of process, so it is so to say relatively you need to have relatively deep in the understanding what that does this thing do. If we go forward, the network detection side, there is, well, you need to find a proper place where you can tap the traffic. Some places, because of the high availability, they might have hundreds of network switches there. So and they are not kind of typical traditional star-shaped network. So it can be really difficult to actually tap the right locations. And of course the physical tapping might be difficult because some of those environments are just physically so wide that you cannot just aggregate the data using a couple of simple devices. If you want to gather the net flow, some switches may not be able to generate, and some of the switches might think that some of the operators might feel that if this affects even a couple of percentages of the performance of the network, they are not willing to risk that. And in some cases, you might need data diodes just to make sure that and prove that you are collecting data in non-intrusive way. And in the deeper side, on the true OT side, there the protocols are going to be really much different, and well, they might be even, so to say, misusing the TCP/IP stack. So what I'm trying to say with that is that they if you block some put some normal IDS there, they start to immediately yell about the kind of the protocol type of attacks and so on. So you might need to tune them quite heavily. But at the same time, on a network level, these are relatively stable environments. So you should be able to baseline these, and you should be able to identify every single device there is. And for the endpoint detection side, first of all, there's a slight chance that you are not able to install any agents, or at least the agent installation takes time because there's a lot of testing in the multiple testing environments before you can put agents in there. And if you want to put agents, there's a slight chance that the operating systems are not supported anyway for your EDR, and then of course the kind of the automatic blocking because of the high availability reasons, automatic mitigation things might be kind of out of the scope for many defenders, at least in the beginning. And so for that reason, the EDR type of things might be better starting point. So just monitor not to block anything. And with those, you can easily use some kind of honey traps or honeypots to kind of improve the detection capabilities. Yeah, but still, in many environments, the endpoint agents you can install, at least in the, so to say, layer 3 side on the engineering workstation, HMI workstations, and so on. And if we jump to the promised use cases, I listed a couple of them. These are also in the book mentioned. For many of these, I will spend, by the way, 5 minutes maximum for these handful of use cases, and then we have more than 5 minutes for the questions. So now would be the really good time to draw the questions. Then I can try to avoid them. But the asset detection. See, this this environment has been quite much, so to say, black boxes for the operators, and there's many external parties. So it is not that clear that although you should know what is in your environment because it's highly business critical, there's a slight chance that you don't know. And the typical, the number one use case for many of the OT people, and also in the IT side, is that you just need to know the assets, just to find out if you have rogue devices or new services popping up, or some traffic profile is changing in the network. And you can get that information from NetFlow. Of course, if you happen to have some kind of UEBA to analyze that, that's even better. But just simple NetFlow collection would work with the open source tooling and so on. The NDR OT security boxes typically do that quite well, and of course the network logs, firewall, and that type of DNS logs, if you collect those. So the number one use case that I classify as essential is that. Almost that as important is the kind of the understanding what goes through your, so to say, normal traffic and the kind of the DMZ layer. So who manages the environment and who are using the internet connections. Typical story is that, hey, we don't have any internet connections here, and then we put some network detection tool there, and suddenly we just have bunch of these weird looking connections that are policy violations. They might create kind of holes in the network, like mentioned already in the attacker side. The same type of tooling there, NetFlow and NDR and firewall and other packet analysis are helping you here. Essential level use case again. The third use case is to actually know what type of malware you are having there. Ransomware and rats and worms and other type of malware, and in that layer level 5 to 3, you could use, so to say, normal type of IDSs and normal type of EDR tools and so on. Of course, you might need to tune them quite a lot, but that is, so to say, the life, and of course we make sure that you can, for example, get the data from the engineering workstation, and you can monitor and run some kind of security operations there. But yeah, the typical sources there from the network, and also the endpoint detection side. The fourth use case, by the way, this previous and this one is also what I call risk aware, so a little bit more advanced, but still not too highly advanced thing, is to actually understand the OT side of the assets. So what OT assets that you have in the network, and for that purpose, there's a separate OT sensor tools that understand the protocols and to go a little bit deeper. They might understand the malware as well. But the most important thing that they do is that if you just allow them, they will talk to your devices. They will say that, hey, you look like Siemens S7. You look like you speak Siemens S7, and who are you? What is your software version? And they communicate, and in that way build relatively nice kind of asset database for the environment that you have. And then of course it helps you to detect what is going on in there. These tools are they are really useful, especially for that purpose. They can do many other things, but still, my recommendation is that you do, so to say, the basics first, and then continue on that. And the last use case that we are going to cover here is that I classified this or rated this that this is a kind of advanced type of thing, is that you actually understand the protocols and the malwares and anomalies in those protocols in the so to say the real OT world. And the same sensors, they are doing that. The main problem here is that, as mentioned earlier, that the network is going to be really wide, and it's really difficult to tap that, get that all the information in. So building kind of comprehensive picture of all the environment can be surprisingly tricky. But with that you could identify like rogue firmware updates and that type of things. Yeah, I spent my time here, and now it would be great time for the questions.
Thank you, Pietari, for the presentation. There are quite a good questions, so let's start about career paths. Mr. Hyppinen recently recommended for anyone wanting to get into cyber to find a niche that they are interested in and fully dedicate themselves to study of that niche. If one wanted to get into OT/ICS, where would you recommend for them to start at?
First of all, the normal IT, you can basically go and get the devices and start the testing. The OT side is a little bit more difficult, but luckily, first, for example, in the Tampere University, the co-writer of the chapter in this book, the Jari Seppälä, is having his automation security courses that I believe that you can do in the Open University as well. Many of these things can be handled kind of using the software versions of these, having Raspberry Pi and running these. So just playing around. We in MPK, we are having some trainings, not specific for these, but in the larger exercises that we organize, there is OT element basically always. So those things you can get the kind of training, and of course there's an emerging market for the vendors in there. So you could just go through those materials as well. And I believe that many companies this is such a hot topic currently. So if you have enough interest and there's a slight chance that you can get kind of junior position in OT specialist in certain companies.
Okay, cool. Are there any OT devices that are suitable for public internet?
I wouldn't call them OT devices anymore, but more like IoT or so. As far as I know, that none of those OT devices should talk to the internet like directly. Of course, you can have multiple type of VPN things, and remote management will come, and the Industry 4.0 will come. But I would be really kind of afraid if anything else but honeypots will be open for the internet.
Okay. And then, do you have any cool war stories to share about ICS? Can you share anything?
Yeah, I think that you can Google multiple, so to say, cool stories. None of these are cool because typically it's very expensive for the victim. Stuxnet, of course, everyone knows the Project Zero Day was the book, if I recall right. There's a great book about that and documentaries in the YouTube as well. I have to check if that was the book. And of course, the Triton and Havex malwares you should check out. There's actually great documentary about this kind of the overall picture here. That is called, I think it's American Blackout. So less than 10 years ago, 7 years ago, the Department of Defense evaluated that what is the kind of the biggest threat for the American nation, and the biggest one, of course, was the direct hit with the nuclear weapons for any major cities. But the second biggest one was that the large scale power outage for example, because of the cyber attack. And that at least I have checked that from the YouTube, and it's one hour long, and it's more about the how we humans start to behave if we have to live 1 week without the electricity. Of course, the Remes books are quite good if you want to scare yourself. But the war stories, they are, what we have, for example, in Finland, they are typically quite sad. Some ransomware type of things, and yeah. Of course, I have to mention the Ukraine power outage in the Christmas Eve or day before Eve, a few years back as well.
So then let's take a last one. How would you keep your USB stick malware testing station updated?
How do you update those stick?
How would you keep those updated?
Yeah, like any other devices in the closed networks, you either manage them. There's some kind of central management, or you stick a USB stick inside those devices. But the same problem, of course, with everything, all the patching there. Yeah. Cool.
Thank you for the presentation, and we will have a short break before the last talk of the evening.
Okay, cool. Thanks.